Hi, so I'll kind of do my 5 minute rundown on my final project. I did it on evolution and phylogenetic trees. The standards I'm addressing are Bio 3.4, basically evolution and natural selection. The misconceptions around this are that we all do not share a common ancestor, and that's, of course, untrue. All life does. And I chose this kind of module and misconception because I'm actually coming from a geography and generation that was not taught evolution in school. So 2 decades ago in Missouri, it was not on the Common Core. So this is kind of me addressing an issue that I had to deal with growing up. My high school, this is for high school biology class. The standards are right there, as well as the misconceptions that this lesson will address. The lesson is blessedly pretty straightforward. The two technology tools are the Novo's virtual lab, and here is the hyperlink, wherein students will be shown videos about evolution, and then they'll be given a lot of problem sets, and they'll have to generate phylogenetic trees based upon traits and DNA evidence. And this is a very subtle but very powerful way of driving home the fact that everything's related, but that things change over time, that there are adaptations and natural selections. And then finally, to drive home the point of the interrelatedness of everything, I will introduce phylogenetic software, as well as a couple of case studies like, is this tuna what I think it is? And is this romaine lettuce going to get me sick? So we're using the fact that all life is related to ask these questions and look at DNA sequences to get the answer. So if life was not all related, we couldn't use DNA sequences to answer these questions. So it's reinforcing it, but gently. Here's my concept map. I start with my misconception. It was learned from either internal sources or external sources, and you can imagine this is family, friends, church groups. And also the internal sources, the inability to kind of visualize what's going on because it's all on a time scale we can't even imagine. And the technologies I use are the virtual lab and the phylogenetic software. And through different ways, we actually will correct the misconceptions, either morphological data, DNA sequences, forensics, and real-world applications. So it's a nice concept map. The technology, once again, the virtual lab I used from PBS Nova. It's a great lab. Students generate their own trees. Then the phylogenetic software, which it's kind of this odd virtual lab slash simulation slash actual experiment. It's a very gray area, but I still lump it in with virtual lab and simulations because it is an in silico experiment, so it is technically a virtual lab, even though it's still an actual lab. And there's hands-on experience downloading sequences to generate phylogenetic trees. And this is just enabling students with technology because they can take this and then answer other questions. The differences in the technology, the virtual lab is educational, but really it's more for entertainment value and educational value. It's not enabling the students to go off and answer their own questions. The phylogenetic software can do that, and so you can actually go further and have them generate questions for further experiments and things. So more inquiry based for that. A brief comparison of how they look. The virtual lab is exceedingly well designed. You plug in these balls, which are the traits, into the trees that you generate, and if it's incorrect, it'll let you know. And then the phylogenetic software, this is kind of where the technology's at, sequencing data that will then generate phylogenetic trees based on that look like this. So my reflection, the technology was appropriate. The pedagogy, the virtual lab is really good, but if you want to enable inquiry-based science, stick with the phylogenetic software. The content knowledge, you really have to have a fairly decent grasp of phylogenetics and bioinformatics, I think. But that's the way science is going, at least biology is going, so I feel like that's a reasonable ask. The student needs to understand computers as well as able to recognize patterns. Pattern recognition is very important for the Novo lab. And the outcomes, the trees are kind of the best ways to visualize evolutionary relationships, And so that's why I rely so heavily on them for this lesson plan. So that's it. Thanks, everybody.